Welcome back to Tech Talk Unplugged, where we dive deep into the fascinating world of technology and systems design. Today, we're exploring the intricate landscape of distributed systems, a topic that's crucial for anyone interested in cloud computing, data management, or system reliability. So grab your headphones, settle in, and let's get started. All right, folks, let's jump right into it. Distributed systems are everywhere. Think cloud services, online banking, and even social media platforms. But managing transactions in these systems is no walk in the park. One of the biggest challenges we face is the read, modify, write cycle. This is where multiple clients try to read and modify data at the same time. Imagine two people trying to edit the same document simultaneously. If they're not careful, they could overwrite each other's changes, leading to data loss. To tackle these issues, some systems implement a feature called snapshot isolation to prevent anomalies like these. However, here's the kicker. While snapshot isolation can help, it doesn't guarantee complete protection. Only serializable isolation can offer that level of assurance. So what does that mean for us? It means that if we want to ensure data integrity in a distributed system, we must be mindful about how we handle transactions and isolation levels. But wait, there's more. The challenges don't stop there. Distributed systems also grapple with issues like network unreliability and partial failures. Picture this. You're in the middle of a transaction and suddenly the network drops. Or maybe one of the nodes in your system crashes. These scenarios highlight the need for robust fault tolerance. Now, let's contrast this with high-performance computing. In that realm, we often deal with total failures when a system goes down completely. But in cloud computing, the game changes. Here, we need continuous availability, which means we can tolerate individual node failures without bringing the entire system to a halt. It's a delicate balancing act. So how do we design systems that can handle these faults? One key approach is to implement error-correcting codes. These codes help ensure that data is transmitted accurately, even when there are occasional errors. Think of it like having a safety net that catches mistakes before they become bigger problems. We also rely on reliable transport protocols like TCP, which stands for Transmission Control Protocol. TCP is like the dependable friend who makes sure your messages get delivered, even if they have to navigate through a bumpy network. It manages packet loss and ensures that data arrives in the correct order. Now here's an interesting twist. In distributed systems, fostering a sense of suspicion and caution can actually be beneficial. By creating controlled failure scenarios, we can test how our system behaves under stress. It's like a fire drill for technology. Better to find out how things fail in a controlled environment than when everything is on the line. You might think that a system's reliability is only as strong as its weakest component. But here's the good news. It's possible to enhance overall reliability using less reliable components. For instance, those error-correcting codes we mentioned earlier can help ensure accurate data transmission, even if some parts of the system aren't perfect. So what's the takeaway from all this? When designing distributed systems, it's crucial to adopt a proactive approach to fault management. We need to think ahead, anticipate failures, and build systems that can gracefully handle those failures when they occur. In conclusion, the world of distributed systems is complex and filled with challenges, but it's also full of opportunities for innovation. By understanding the intricacies of transaction management, fault tolerance, and reliability, we can create systems that not only function well, but also stand the test of time. Thanks for tuning into this episode of Tech Talk Unplugged. We hope you found this discussion on distributed systems insightful. If you enjoyed this episode, don't forget to subscribe and leave us a review. Until next time, keep questioning, keep learning, and keep innovating.